Well, good morning, YouTube. Today's project, we're going to try to install an exhaust brake on Goliath. Some of you may know Goliath has a Jake brake on it, but only 2 of the 3 stages are working properly. So I thought that the addition of an exhaust brake might help make up a little bit for what it's lacking with not having that 3rd stage of Jake's working properly. And now, before some of you say, well, just fix the Jake brake, well, it's not that easy. The reason the 3rd stage of Jake brake doesn't work, and actually technically it's the 1st stage of Jake brake that doesn't work, stages 2 and 3 are what's actually working, but dynamically it works the same. The problem is the head is broken where the Jake brake assembly actually bolts down to the head, so I can't physically attach it. So my only solution to repair it is to completely replace the head. Now the problem with that is this is a perfectly good running Detroit 60 series. There's nothing wrong with its engine operation. So I have a hard time taking off a perfectly good head and doing a job that could cause engine problems in the future when it really just isn't necessary. And part of my reasoning behind that is because I cannot find an OEM Detroit head to replace it with. All I can find is aftermarket stuff. Looks like most of it is made in China. Some of the tolerances aren't as good. And when I talk to people that are in the know, they say, stay away from the aftermarket heads. Only use OEM Detroit products, which I just can't get. So for right now, the Jake brake is not going to get fully fixed. So this is our next option. And with that said, at some point when I do fix that, then the exhaust brake will still be functional. It'll still add that extra level, because truth is the Jake brakes on the Detroit 60 series really aren't that good and strong. It's not like they are on these new Cummins with the variable vane turbos and stuff like that. So having the exhaust brake will still give us that exhaust back pressure that kind of make up for what the newer trucks do with the variable vane geometry. For those of you that don't know the difference between a Jake brake and an exhaust brake, we'll touch on it really quick, but we're not going to go into a lot of detail. So when you hear the term Jake brake, it is actually just a slang term for a dynamic engine brake. And the slang term is because the original company that invented it was called Jacobs Braking System. And so it just kind of became known as the Jake brake, although technically it is a dynamic engine braking system. How it works is there's a second set of valve actuators on top of the engine that will open the exhaust valve at just the right time, so that when that fuel injector squirts fuel into the combustion chamber and that cylinder fires, rather than it driving the piston down to keep the engine running, it allows that force to escape out through the exhaust. And by bleeding that combustion pressure off to the exhaust, it actually turns the engine into a retarder. So now the friction of the engine turning will actually start to slow the vehicle down. Whereas if that valve were to close again, then the ignition process would actually power the engine, which would then power the drivetrain if everything's still engaged. Granted, it's at 0 throttle position, but the engine would still be at idle. Therefore, it would still be turning under its own power. The way this works is it's not turning under its own power. All that energy is exhausted through the exhaust stack, which is why you hear the loud noise on unmuffled engines. But now the drivetrain is what's actually spinning that engine over. And so you do get that braking ability. Now, an exhaust brake works completely different. It is literally a valve that is in the exhaust system. And when that valve closes, the pressure that's coming through the exhaust system cannot escape as easily. Therefore, it will build pressure and slow the engine down. So keep in mind, pistons are moving up and down inside that engine. Every time they come up in that exhaust stroke, they're pushing air out into that exhaust system. If the air gets trapped, then you get resistance on that piston coming up. So it slows the engine down as well. By itself, truth is, it probably doesn't work as good as a Jake brake does, but I think in conjunction together, we might get the results that we're looking for. Now, I have an exhaust brake on my 7.3 Power Stroke truck that's in my Excursion. However, I didn't install it. It's actually a valve that was already in the system from the factory. I just took control over it. So it was never used as an exhaust brake, but I can now use it as an exhaust brake because I took control from the computer and made it manual. And I saw a good result with it, with all those years of driving that truck on the road before we moved up to Goliath. Hi guys, check it out. Flip just showed up. You guys remember Flip. He's ridden with us before, and he has his own YouTube channel called Flip and the Mule. I don't know why I can never say it right. Flip and the Blue Mule.
That's the mule.
That's the mule. All right, so we had a nice visit from Flip there for a moment, and he actually gave us a shirt that we thought might fit Katie, but we haven't given it to Zach or something. It's a little bit small for her. But anyway, Katie also came up and took my truck. She rode the Riker up and dropped it off. She's got to go grocery shopping. So now it's time for me to get back on this. All right, so if you look at the current exhaust system, here's your turbo with the flange, and then that pipe runs back and disappears under the truck. If you look down here, it runs right under the cab until it turns out right here. Now, there is a piece of flex pipe right there. So I want to make sure not to put the exhaust brake back that far. The closer you get to the turbo, the more efficient it is. And also, I think the easier my installation will be, because trying to fit it in back in there is going to be challenging. Not that it won't be here. You see, I might have to relocate the dipstick, but I think I can get it to mount here and come up this way and still have access for all the hookups. But that way it's very well supported with the exhaust manifold. Plus this pipe has got a bracket right down there where it bolts to the frame. So there'll be support on both sides of it, which is a good thing. You definitely don't want it past any of the flex pipe, because flex pipe just isn't as strong. And with the back pressure building up, you got more potential for blowing the pipe apart or causing leaks or whatever. So we want to make sure that it's fitted in with the hard section of pipe no matter what we do. So I think we're going to start with as close to the turbo as possible and go from there. All right, so this is the Blue Ox exhaust brake. Now, this is what's considered a guillotine style. There are two different style exhaust brakes. So here's the actual exhaust flange. There's one that's got the valve that opens and closes, and then this one's a guillotine. So in here, there's basically a blade that will come down and shut it off completely. And apparently that's the more powerful and more reliable system. And not that we're a high horsepower application by any means, but these also have a better flow characteristic because the blade isn't in there in the way, you know, for that valve to have to open and close. So when it is open, you have unrestricted airflow, where the other ones, you've got that blade in the way. In addition to the actual exhaust brake, we have the WM901M. This is the installation kit. This is actually the solenoid, the air line, the wiring, everything we should need to be able to hook it up and make it functional. And then here is an additional mounting kit, which I'm not positive I'm going to need other than the clamps, but it comes with the flanges that way you can weld these flanges into your pipe and then mount to the exhaust brake. So ideally, you would take this one and mount it here, and this one and mount it here, and you could weld these into your current exhaust system. So at that point, you just clamp in the brake itself with the heavy-duty clamps. But if I can get it to mount directly to the turbo, I won't actually need any of these pieces. I will just need one of the clamps, because there's already a clamp on the turbo holding the exhaust pipe. If this can mount to the turbo, one clamp holds it there. The next clamp takes the existing pipe that I already have, moves it up against the exhaust brake and clamps on there. Now there is another support down there, so it'll have a support on both sides supporting this weight. And I think that's the safest, smartest, easiest way to do it. So to start with, I need to pull the exhaust off of it and at least slide it back some to see if I can fit that in here with the clearances. They're going to be a little bit tight. Okay, so I've got the entire exhaust system removed except for the upright stack. I gotta tell you, that was complete pain in the balls. Now, it's almost 5 o'clock. When I started this video, I want to say it was just barely 11:30, almost noon, something like that. It took that long to get the exhaust off. Now, my original plan was I wasn't going to remove the flange from the turbo where the little bend is and the straight pipe. All I wanted to do originally was just take out the flex pipe, cut it shorter, move the whole thing back a little ways, put my exhaust brake in, and bolt it all back up. That wasn't happening. If you look down here at how far on they had the flex pipe, there just wasn't enough room to maneuver it off, and it was so stuck on there. I thought with putting this exhaust system on last year, it would still be new enough that it wouldn't be a bear to get apart. But everything was a pain in the butt. So I ended up having to do that and pull the elbow out. But in order to get the elbow out, I had to split the exhaust because I just couldn't get it to slide off. It was just on there that tight. But luckily, we have to shorten the exhaust. And this is just the flex pipe. So that's the part that I wanted to cut if I had to cut anything. And I'm looking at where I cut it. And then I'm looking at the width of the actual exhaust brake. hopefully I can cut that split out of there and it not make the whole system too short. And if it is, no big deal. I'll go get another piece of flex pipe. But if I can avoid buying another piece, would be great. But now I'm out of time today. So I gotta clean up my tools and do a couple more things that I've got to get done today. Not on this project, because we got dinner plans tonight with Mike and Alicia. So I need to go home and get cleaned up because I am an absolute mess. Now the huge challenge with cutting that pipe is this is the area I had to work with, and you can see I've got my tool in there, but I literally had to disassemble the tool and then reassemble it while it was in there to make the cut. All right, so I cut off what I had to split, and if you look here, comparison wise, we are just barely, I mean, literally, I know on camera it looks a little wider, but in real life, it's literally, I think I'm within half an inch. This is a little bit bigger than that, which is good. I want a little room to play. If you look at how much of it was overlapping there, if I take half an inch out of here, I still got plenty of overlap there. But truth is, I'd rather it be just a little bit short. That way I've got some room to play with it once I get it back in, because this pipe has to go back in before I can install the exhaust brake, because once everything is back assembled here, I won't be able to get this pipe in there. So it's at least got to be in there and laying in its place. Doesn't have to be bolted down yet, but it's at least got to be in there. So I don't want to have to take everything apart to cut it again. So I went ahead and cut everything, and then I took my sander and I ran it around the inside of this really good, take off any burrs, and also to remove some of that diesel soot that was trapped on the inside. That way when I do go to reassemble, I'll probably hit with some of that Amsoil NP just to make it a little bit slipperier, and hopefully everything will assemble a lot easier than it came apart. Also, when I was cutting the pipe down here, you can see that I got into this pipe just a little bit. Get the camera. So I'll end up taking this home with me, and I'll weld that back up and then grind it down smooth so it doesn't have a potential leak when it all goes back together. But I think for right now, that's all I can do today, guys. I gotta get cleaned up and go to dinner. And hopefully we'll come back to this project first thing tomorrow morning. Well, guys, before I left, I decided to hold it up, kind of mock it into place to see how it was going to look, and it's not going to work the way I wanted to. So it goes in like this. You can see there's a arrow direction here. The flow goes this way. It clearly says engine side, and well, yeah, just engine side. But I thought that this flange was going to mate up with that flange, and one clamp would hold this to the turbo, and that's just not the case. This flange is designed for the exhaust pipe to fit to. This flange is designed for the exhaust pipe to fit to, but the two flanges don't go together. So I am probably going to have to build a coupler with these two pieces that I thought maybe I wouldn't use. That way, then it can bolt to the turbo and then bolt to the exhaust brake. It's going to push it back a little bit further, but that may not be a bad thing, because the further back in here I get, the more clearance I actually get away from the dipstick and our intake tube. So it may actually work out better, but it means I'll definitely have to shorten that pipe that much more than what I already did. Anyway, project for tomorrow. All right, guys, it's Friday, about noon, a little after, something like that. And I'm back up here at Goliath, and as you can see, I've kind of got the system mocked up in there a little bit, but not exactly. What I did, because I haven't welded these two pieces of coupler together yet, so I just used a clamp at first to clamp it together, just so I kind of get everything in position before I go cutting or doing any welding. And with those two butted together, it pushes it back a little bit too far. So as you can see up in here, this is where the air intake comes in from outside. It nestles up here in the corner, but it's literally right up against a lot of these items here. So I think what I want to do is shorten this by about 4 inches, bring it closer. That gets this up into this area here that's more open. It won't be in the way of the intake. It won't be in the way of any of that stuff. And I'll actually be able to rotate it in some, that way to make sure that the hood doesn't hit it as it comes down. The other item of concern is, as the pipe after the exhaust brake curves and comes down, it attaches to the frame down here, and it's got a good clamp. And right now where that's landing, it's right where the clamp connects those two pieces together. So the clamp that holds it to the frame would interfere with the actual band clamp. So by moving it 4 inches more forward, that should free that up to where it works perfect as well. Everything back here should line up. All we'll have to do is trim a few more inches off of that flex pipe. And once we get this cut to an actual length, then I can just do the math and take off that extra little bit there. Should work out fine. All right, so I'm doing a little bit of math on these and where it's positioned. I think if I do 4 inches, it's gonna be too much taken away. It'll actually limit where I can rotate that to. So I think I'm gonna start with 2 inches. But what I've gotta do is I've gotta take an inch out of this one and then an inch out of this one, because if you look carefully, there's a slight taper in this. And if I take all of it out of one, then the diameter is gonna be different, and matching them up, the weld won't be pretty. So I think if I take 1 inch out of this, 1 inch out of that, then I should still be able to butt them up, get a good weld, and that'll give me 2 inches away from that firewall up there in those hoses, and I can reroute some of those hoses as well. And I think that will work the best. All right, and because I don't have a tubing cutter big enough for a 5-inch pipe, and I'm not really good at getting a good straight cut with a Sawzall, what I did is I took a piece of 3/4 inch tape and I wrapped it around the edge, and I will just take my cutoff wheel and I will cut just the inside of that tape, and that'll give me just shy of an inch, because the cutoff wheel's 1/16, but the actual cutting probably closer to an 1/8 once it's all said and done. And I'd rather start a little small. If I need a little bit more, I can always sand them and clean them up a little bit and end up with my 1 inch off of each one. So we're gonna give those a cut and see how it works out. All right, so I made my cuts, and it was a little bit tricky there for a little bit, because as I was cutting, the tape itself was shrinking a little bit. So it made it look like I had more of a gap between my blade and the tape than I wanted to. But when it was all said and done, I just kind of trusted my instinct and followed my line around. And sure enough, when I got all the way around, my lines lined up and I cut right directly into the cut that I started with, which is pretty good. They came out pretty decent. If you look, they're mating pretty well, all except for this one little spot right there where there's a little bit of a gap. But that will weld up just fine. So now I'm gonna re-mock it up and make sure that everything lands where I want it to land before I go home and weld it. All right, guys, and there is the mock up. Again, this clamp is just there to hold these two pieces together. It will not be there in final assembly, but the exhaust brake is in. The other pipe matches up to it. There's plenty of room up here. I can still get to the top up this way to hook up the air line. These hoses will just get rerouted on the outside when it's all said and done, and it clears everything that it needs to clear. Because it didn't move back as far as I wanted, I still got where this clamp right there goes, and the joint of the pipe is, well, it's getting blurry on me. It's right there as well. So that is gonna be a little challenging right there with that clamp on it, unless I can just rely on that clamp to hold the pipe together as well. And then back here, see our flex pipe ends where this is gonna be going in. So I'm still gonna have to shorten the flex pipe by a few inches, but I think it's all going to work. All right, guys, after going home and eating some lunch, I went ahead and welded everything up. As you can see here, it's a pipe that I'd actually cut through yesterday a little bit. So I filled it with some weld and ground it back down. It came out pretty good. And then my little midsection that we had to put here, got it all welded together as well. Now I know it's not the prettiest of welds. I am not the best welder. I can get the job done. It just isn't always pretty. However, that makes me a really good grinder. All right, so I'm gonna throw everything in place again, mock it up one last time, and make sure that everything still lines up the way I hope it should. And we might actually be able to get this finished being mounted by the end of the day. It's already getting kind of late. It's like 4 o'clock already, but also I gotta find new clamps for this. I don't think I mentioned that yesterday. When I took these clamps off, they were so rusted that they just broke. So I'm gonna have to find some new clamps to clamp that tube back on. All right, guys, and there it is. I think that's gonna work. So this is in a spot where I have access to everything still. It's not touching anything. Now things aren't super tight. I can still kind of move things and shift them a little bit. I can rotate this in or out some like that if I need to, but I think right about there is where it's gonna go. The down pipe after that is all connected, and it looks like I still got room for my clamp down there. Now all I have to do is cut cut the flex pipe short enough so that that piece still fits in. So I think basically what I'm going to do is I'm going to measure my overall addition to the system. So not just the exhaust valve, but the actual spacer that I had to weld up with the flanges. Find out what the overall length of that is. Subtract it from the overall length of what I started with the flex pipe. So I have to subtract what I've already cut off a little bit more, and then it should all fit back together. Keep in mind, there was a lot of overlap. I mean, there's a good 4.5 inches of overlap on that pipe. So even if I'm wrong by like an inch, I've still got plenty of room. And I'd almost rather cut it a little bit short than a little bit too long. So, because too long, it just won't fit very well. So I think we're going to go ahead and do that. Pull out the tape measure, do some final measurements. I'll pull all this apart, make those cuts, and then hopefully we'll be able to do a final assembly. Well, it's kind of just as I suspected. The inner pipe here is just too long. Like I said, it comes like here, so there's a lot of overlap on this flex pipe. Oh, my head's dirty. But basically inside, the two pipes are touching. Before I get enough clearance for the exhaust brake to actually fit in there, I'm shy by like 3/4 of an inch. So I'm going to trim this pipe a little bit so that they don't hit. It'll give me a chance to move that one back a little bit further. There should still be plenty of overlap on the clamping surface. It's just it won't fit the way that it is right now, so got to make some adjustments. Well, guys, in that last clip, it was pretty darn dark, and I was showing you that with a flashlight. That was Friday evening as I was finishing up, and I did not come back up on Saturday or Sunday, and it is now late Monday afternoon. It's almost 4 o'clock, and we were just now getting back to get started on this because we kind of took the weekend off, but I had a lot of other stuff to do today. But as you can see, it is physically installed. So everything is in place, tightened up. The entire exhaust system is now put back in place. It's still crooked as all get out, but it was that way when we started. So there are two more phases to this installation. We've got to hook up an air line to it because this particular guillotine style valve is air actuated. So when air is applied, it will force the valve to close, and then there's a super strong spring in there that will return it to its seat when the air pressure is removed. So the kit included some airline and a solenoid valve. So we're gonna go ahead and run the plumbing part of it done and get that there. Then we gotta run the wiring because there's a control system that tells this valve when to operate. So see here, also came with some wiring and some other fittings and stuff here, and another relay, the switch, so on and so forth. Now, I glanced over these instructions like over 2 months ago when we were in Deadwood, even before the Sturgis rally, when I first purchased this device. So yeah, I'm gonna sit down and refresh my memory on it. But basically, there's an activation switch that's gonna turn the whole system on, which will be on the dash. At that point, there'll also be a connection to the ECU so that when I let off of the throttle pedal, the idle validation switch is triggered in the ECU. The ECU will then know it's okay to turn this on. So the throttle has to be completely released and the switch has to be armed, and then the system will work. So if I don't want to use it, I just disarm the system and I can use just the Jake brake or nothing at all. But if I flip both switches on, I can use both or just one or the other. All right, so after staring at it for about an hour and just thinking a lot about it, I've come up with a plan. I found a port up here on the dash that had a block off plug in it that wasn't being used, that when the engine is running is supplying ample air. So we're gonna tap into there. It's the same port that splits off and goes to the engine driven fan, so that should work well. So right here on the firewall, we have this, there was a block off cap here. So this will be the supply, and this cover normally sits here and covers up all these wires. I'm gonna mount the relay right to this cover, right on the front, and then out of the relay, we'll go down to the brake actuator itself. So the entire air system will only be about 1.5 to 2 feet long, which should make it really easy to maintain and take care of. And with the air relay being mounted to there, I've got all this line, probably 18 to 20 inches worth of the power and ground wires going to the relay. There is a ground block on the firewall just near this, so it'll give me a good place to ground and still enough wire that I can route this inside the firewall to do the relay and the switch and everything on the inside. I've also got to mount this quick release assembly to the top of the actual exhaust brake. So this end here will thread into the exhaust brake. This will be the supply line coming into it. And it's just designed that when that pressure begins to drop, when the air is taken away, this will quickly exhaust what's in the system to allow that exhaust brake to open at a very fast rate, so that when you're getting back on the throttle after letting up off the throttle, there's a minimal time between that valve opening and you requesting power from the engine. So I've just kind of got this stuff pre-assembled and mocked up. So now I'm gonna go grab my thread sealant and I'm gonna pre-assemble all of these fittings into here. I'm gonna pre-assemble all of these fittings into here. And then I'm going to put this fitting into where our supply is gonna go. And then the hose that comes with it is just a push-on type. So they say to lubricate the inside of this, push it on and then kind of jerk it real quick and it grabs and bites. No clamps necessary. We're gonna try it. If it doesn't work, I can always add clamps to it. All right, guys, so here's the system. See, there's where I tapped in for my supply. That hose loops and it tucks back in behind most of the stuff here. Comes over to the air solenoid. I drilled the small hole in the firewall right up here and installed a rubber grommet, which I still got to get in there a little bit better, and wrapped the wire so everything was nice and neat. From there, the hose comes down to the actual exhaust brake. Well, you can't see it there. Down to the actual exhaust brake, right down there. And as you heard in that last clip, this system is working. Now I don't have everything else inside wired up. I literally just have the wires for the solenoid run to the inside of the cab, and I was using my power probe to activate the solenoid to make sure that the entire mechanical system was working properly. And as far as I can tell right now, it is. There's ample air supply. The second I hit it, it pretty much closes. The second I release it, I can hear the dump valve dump, and you can hear the change in tone in the exhaust. So in here, I've got the dash pulled apart in Goliath, and these are the wires coming from that solenoid. You can see where I've got my power probe temporarily hooked to it. There is a ground right here, so that solenoid is going to get grounded right there. And then it's a matter of running the inside activation switch and the idle validation switch, as well as the relay. There's a spot up here where I'm going to mount the relay to one of these bolts. And I've got a couple bolt holes. You see in here, I think I'm going to put the switch right there in that hole, because I'm not using it for anything right now. Now, part of me thought about putting the switch on the dash somewhere near the Jake brake switch, but I didn't want to accidentally hit this switch when I only wanted the Jake brake, or vice versa. Not only that, but I really don't want to drill any more holes in my dash. All of the switches that are in the dash right now are factory placed switches, and the trim panels are all designed for that. So I really don't want to go mucking any of that up. I want to kind of keep some of this as original as possible. So until I make a final decision on what I'm going to do with the interior, I just don't want to make a decision that I can't come back from. So I've got an empty hole sitting there that was designed for a toggle switch. So that's where I'm going to put the toggle switch. It'll also make it a little bit easier for me to route the wires up under the dash. So that'll work for now. It's still an easy reach from the driver's seat, and it's in a spot where I'm not going to accidentally turn it on either. So now the only thing left to do under the hood is run the wire for the idle validation switch. And that is in the ECU, which is right down here on the driver's side of the engine. So I've got to pull out the plug. The kit came with a map of the plug diagram, and it tells me exactly which pin on that ECU connector that I need to connect to. And it comes with the connectors and everything. So all I can do is pop that connection in there, route the wire inside, plug that connector back in, and then on the inside, I can run that wire directly to the relay. But once that wire goes inside under the dash, I'm done under the hood. Then it's just a matter of hooking up the relay and the switch on the inside. All right, and here you can see where it comes with the instructions to show exactly how to wire everything. And it shows for DDEC 1, this is the plug I'll be using. You got also for DDEC 2, and there's some instructions here for DDEC 3 as well. Now guys, remember Goliath is a 1987 and this is the original engine. But 1987 was also the very first year for the Detroit 60 series. That's when it was debuted. So it's actually pretty rare to see this engine combination in this truck. But we're kind of lucky there because DDEC 3 and beyond, you've actually got to go in and program the computer, and I don't have that ability. But for DDEC 1 and DDEC 2, there's no need to. It's already in the program as far as which terminal to use for idle validation. So here it says I should use H1. So you see, this way they're labeled alphabetically, this way they're labeled numerically. That is the terminal I want to use right there. It's H1. So I can go find that plug on the ECU. All right, guys, so I want to grab the flashlight because it's getting kind of dark over here. Now you can see that there are 3 plugs on this side of the ECU, but they are all single row plugs, 4 and 5 wire systems. It is not one of those. It's either going to be the black one on the back side, or there's another one down there below it, which you can't hardly see. I don't know which one of those two it's going to be. Well guys, after spending a little bit of time with Google Assistant trying to figure out exactly which plug I need to pull, I may actually have DDEC 2. This whole time I thought I've had DDEC 1 because there is a small module under the dash that just says DDEC on it. And of course, when they first came out with DDEC, they didn't call it DDEC 1 because at that point they didn't know there was going to be a 2. But every time you find something with DDEC 2, it says DDEC 2. Now, I can find images for the ECM or the ECU, whatever you want to call it. And what's on my engine looks like all the pictures I can find for DDEC 2. Now, I can find images for DDEC 3 and 4, and they have a completely different plug configuration. But I cannot find pictures of what the DDEC 1 ECM looks like. But what I did find is that DDEC 1 was a dual box system. So apparently there was an ECM inside the cab of the truck and then just an injector driver module on the engine. But what's on my engine looks like what's DDEC 2. So I may have DDEC 2. So either way, it's going to work out the same. I just got to know which plug to pull. Another thing that makes me lean towards believing it's actually DDEC 2 is when I'm looking up the differences between DDEC 1 and DDEC 2, other than the dual box system, DDEC 2 also incorporated the use of cruise control to make the engines more efficient. Well, Goliath has cruise control. I use it all the time. It works. So that also makes me think it might be DDEC 2. But to make things more confusing, some people are talking about staying away from the DDEC 1 because it was just kind of a hard system. And they mentioned like the green engines, and then they went to the silver engines. So they're saying like stay away from the green, go with the silver because that's DDEC 2 or maybe 3, whatever. I'm confused because my engine's blue. It's not green or silver. Well, it's an absolutely beautiful sunset, but unfortunately that means I'm running out of light. I've got one of the ECU plugs out. The other one just have no room to like turn the ratchet, so I'm gonna get in there and try it with the power ratchet. I broke it loose, but I just can't move my hand in there. The one that I pulled out isn't labeled as far as which numbers they are, so I'm hoping that the second one will be. There is a little bit of corrosion in there too I gotta clean up anyway, so it's probably a good thing we're doing this. All right, guys, it's pretty well dark and the frustration continues. Let me show you kind of what's going on here where I'm still confused on DDEC 1 or DDEC 2. So here in the diagram, you can see where it's showing the style of plug for DDEC 1 and this style of plug for DDEC 2. And they look different in the picture. But what I'm really looking at is, see at the bottom of this plug here? Let's see. It looks like there's an opening on the bottom of the plug. Looks different than the top. And with this plug, everything looks circular. Well, if you look at my plugs, I've got that cutout on the bottom. To me, this looks like DDEC 1 plug. But I've got 2 plugs in this. Where'd the other one go? Well, we've got 2 plugs. The one that goes on the top side of the ECU, every single terminal is full except for one. and it would not be the one that it shows to put it in. No. And then on the bottom plug, which I think is the sensor harness, because you can see where there's a split off here, and this harness just goes over to the fuel filter sensor right down there. I know it's kind of hard to see in here, guys, right down there. But in that harness, I have blank spaces. And if I turn this plug to the orientation that it shows in that picture, the space that I need to go to, which is circuit 508, is blank in this one. So that makes me think that that's where I'm supposed to go, but I'm just not positive. And you can see here on the wiring diagram that all it does is go up and control the relay, which should be grounded on the other side. So in theory, that lead should have power when I release the throttle, and there is 0 throttle input. The idle validation should put 12 volts onto that circuit, which would activate the relay right here, which would then allow power to come through from our keyed power through the relay to the on-off switch, and then everything on to the solenoid. So I think what I'm gonna do for now is I'm gonna put the proper terminal on a wire. I'm gonna fish it through the plug on the one that I believe is the right one. I'm gonna plug everything back in. Now I'm not gonna connect the other end of that wire to anything because I don't wanna take a chance on frying my ECU, but then I can just use my power probe and I can test to see if there's voltage there when I let go of the throttle pedal, and when I apply throttle, the voltage should disappear. And if that works, that's really all I need to know, and then I can wire it into the system. Well, unfortunately, that didn't work. So I've got the wire connected, run all the way through, and in theory, I should have power to that when I turn the key on, and I didn't. But I went ahead and started the truck up, still no power. I gave it throttle, let go of throttle, nothing changed. There was no voltage there. So it definitely will not activate the circuit. So back to the drawing board, but it's getting kind of late already. I mean, as you can see, it's pitch black out here now. Yeah, so it's like 8:30 at night. So I think I'm gonna call it quits for the night. I'm gonna go home, take a shower, and I am just gonna sit down on the iPad and just do a bunch of research and see if I can't figure out exactly what I've got before I go and make a mistake. Last thing I wanna do is like hook to the wrong thing and burn out the ECU or something like that. I mean, that would be very problematic. We don't wanna go that route. Worst case scenario, I do have a micro switch on the foot pedal that activates the Jake brake. I guess I could just source that as power. And then in theory, it would turn it on just like it would turn on the Jake brake. Even if the Jake brake wasn't turned on, I think that would still, I don't know, I'd have to check all that stuff too, but just thinking out loud. But for now, I'm gonna clean up these tools and get home, get a bite to eat, take a shower, and then do a bunch of research. Well, guys, my frustration continues. So it is the next day. Again, it's late in the day. I had to take Katie down to Atlanta for a doctor's appointment earlier today. So I didn't actually get up here to start working on Goliath until about 3 o'clock. And now it's about 4. I've got kind of an hour into this and I'm still not finding my idle validation circuit that I was looking for. But I think that I pretty much have decided I do have the DDEC 2. You guys remember in other clips, confusion with the plug styles. Even though my plug looks like the one that says DDEC 1, the DDEC 2 plug, it says to use position A1. Now, if you remember, here with the DDEC 1, it says to use H1. I used H1 and it didn't work. So here it says A1, and it clearly says in the instructions here that A1 will be for circuit 508. Well, I removed the ECM today. I got the numbers off of the ECM. I actually found a company that specializes in ECMs. I talked to them on the phone. They said to send them some pictures. I did, and now they won't reply to me. So I don't know what's going on there. But I traced the wire in position A1, which would be for DDEC 2 that it tells me to go. And the wires are actually all numbered. And sure enough, that wire's got a number 508 on it. So leads me still to think I'm DDEC 2. The computer looks like DDEC 2. The wiring code looks like DDEC 2, even though the plug looks different on here. But nonetheless, that circuit does not have the signal that I need. I even checked the H1, because where I did the H1 before was actually on the wrong harness, but none of them are working. I cannot find the signal. All of these other leads have actually got power whenever the key is on, but it remains powered even when I give the truck throttle, and it should only have power when the throttle is released. So I don't know, back to the drawing board. So as you see, I got kind of a mess in here, and I've got these wires here that all come from the ECU, and some of them are not connected to anything. And unfortunately, none of them are doing what I'm to do. They all have power with the key on, but none of them will remove power when the throttle is depressed. So I'm almost thinking about going down to our little needle switch here. So basically this is the switch for the Jake brake. So when the Jake brake system is powered on, the power comes through the clutch switch, which is up here, and then down to the throttle switch. So if I press the clutch in, you'll hear a little click. That's a little micro switch up there disengaging, which will cut power to the Jake brake system. After that, it comes through to this switch. Same circuit, just two switches in line. So if this switch is out, now this switch has power. And when I give this throttle, here where it clicks, that turns off the Jake brake. That turns on the Jake brake. Now I need to adjust this a little better because it's a little bit delayed. So I'd actually considered just wiring this to that switch. That way it would still turn off whenever I gave it throttle. The problem is the way that the Jake brake is already wired in here, when I activate the switch up there, it then sends power through all this. So for that to work, the Jake brake would have to be on in order to use the exhaust brake. And I'm not sure that I want them to always work at the same time. I mean, in theory, I'll probably use them at the same time, most cases, but there are times where maybe I'm only gonna wanna use one or the other. So I don't really want them tied that way. I'll still have the switch for the exhaust brake, which I can always turn off, but the Jake brake would have to be on for it to work. So I could still use the Jake brake without the exhaust brake, but I'd never be able to use the exhaust brake without the Jake brake. Well, hey guys, I'm back. I know for you it's only been a couple of moments, but for me it's actually the next day. I think the last clip we were talking about trying to wire the exhaust brake so that when I let off the throttle, it automatically engaged. I gave it throttle, it disengaged, using the ECM to trigger that. And I was very unsuccessful with that. So the only way I could have made it work with the pedal and the switch that's existing on the pedal would be to completely rewire the Jake brake system as well. And I really didn't want to get into that. So as I mentioned earlier in the video, I think, because that was days ago, I've got an exhaust brake rigged up on my Excursion as well with a 7.3, where I took control away from the computer, put a manual switch on it. And no, it doesn't automatically release when I give it throttle, but I know to turn it off before I give it throttle. I'm not saying I've never forgotten, but usually you know right away that it just doesn't deliver power. So I decided to just go ahead and wire this to where when I flip the switch, it comes on and it stays on until I flip the switch off. Now what I did is I have this switch right here for the heated mirror, and that is what I have it rigged to. So let's see if you can hear it when I turn it on. So yeah, Goliath has heated mirrors, but we never use them. Truth is, I don't even know if they work. All the years we've been driving Goliath, we've never driven it in sub-zero temperatures where we really needed it. So I figured rather than drilling a hole in the dash or having to run new wires, there was already keyed power to that switch and already a line going out over towards the mirror. So basically I intercepted that line and ran it to the relay. Now I did have a problem with the relay. So I'm not talking about the air relay. So there's an air relay that you saw me put under the hood, which is kind of like a solenoid more than a relay. But then there was actually another switched relay to where when you let off the throttle, it would trigger the relay. When the relay closed connections, it would then send power from this switch to the actual exhaust brake, and I decided to bypass all of that because that relay was bad out of the box. It had a dead short inside it, and whenever I tried to hook power to it, it would trip the breaker or the fuse, so I bypassed it. So right now we have key switched power going through the switch on the dash directly to the solenoid on the firewall that allows the air to flow, and then to a ground. It's a real simple system. It's exactly the way it needs to be. I would have liked to have the pedal feature, and maybe we'll do that in the future, but for right now, we did this. So anyway, the next step here is to tune the system, because the Detroit 60 Series engine is rated to have, I believe, 40 pounds of back pressure maximum. And the reason for that is because anything more than 40 pounds could actually overcome the pressure of the valve springs and cause an exhaust valve to hang open. So we don't want that to happen. So I've installed the gauge in here so that we can tune it. So I went out and I picked up a liquid filled pressure gauge, 0 to 100 PSI, and I ran that all the way out to the exhaust valve itself. There was a plugged test port on it in order to test it, but I think I'm going to just leave this hooked up. Now I noticed that here at idle, when I engage it, I get about 20 pounds of back pressure. Now obviously that's at idle, and when you're going down a hill in a gear where you're running max RPM, which on this engine is about 2100 RPM, and no, I don't typically descend a hill at 2100 RPM, but 1800 is pretty common. So I want to make sure that at that RPM range, we don't exceed what is safe for this engine to handle. They also say that at idle, we should see a 25 to 50 RPM drop. So you can see it stumble it, but then I think the computer compensates for it. So as you can see right there, there is an appropriate drop in engine RPM, but then I think the computer then kind of senses the load and it's adding more fuel, so it slowly climbs back up there. But we're gonna call that good for right now. I've disconnected the trailer. We're gonna go road test it, bring it up to full operating temperature, and then we're gonna see if everything works. Well, that was an epic fail. The exhaust brake's working, don't get me wrong, but my gauge didn't last but a couple of moments. I guess the PVC line going to it, when that exhaust brake is on, it's blowing really hot air into that line, which I knew, but I was kind of hoping it would still work. And it instantly melted the line off of it. And then now it just has an exhaust brake leak. There's a lot of pressure coming out of that exhaust when it's on. So that's even at idle. So I got to come up with something that's going to withstand the temperature of that air. And I don't know how I'm going to do that just yet. All right, so I ran back out to the store this morning and I got some copper tubing, same size, still 1/4 of an inch, but at least the copper tubing isn't going to just melt away with the heat of this exhaust. So it was a little bit more difficult to work with, but we got it in here. And let me show you what I did right in here. I put a loop in it, not really a loop, but a high point for thermodynamics. All right, so right down here, obviously, is where this connects into the exhaust brake. And right up here is where it goes into the firewall. So I put that little loop up top, and I did that because heat rises. Now, I don't really know how hot and for how far that pipe is going to get hot. But in theory, if it's just registering pressure, there shouldn't be a lot of air moving through the pipe because there's already air in the pipe. Therefore, once the brake is closed and that pressure builds, it should just push. It shouldn't actually travel through like a full exhaust system. So I'm hoping that the heat won't carry too much under the inside of the cab, because obviously that copper line gets hot. It's tied up with zip ties. It's running by other wires and stuff. We don't want that to be a problem either. So the loop, as it comes out, I got it going up and then coming back down and then into the firewall. And I did that because heat rises. So as the heat travels up that pipe, I want it to kind of get to a point where it dissipates more than it travels down. Now I know there's still going to be some heat transferring into it, but in theory, if I put the high point before I get to anything that's hot, it's less likely to travel down than it is to travel up. And I know it seems like a minor difference, but sometimes these little things help. You know, it's kind of like when you're trying to solder copper together or weld copper together, you always use your solder above the joint that you're heating rather than below, because even though it will suck it in, it works a whole lot better because of the natural convection of the heat rising. So now I guess it's time to fire this thing up and we'll go try to test it again. Hopefully it'll work this time. All right guys, so I made it up the road a little ways and it looks like the new pipe is holding up very, very well. You know, I checked it for temperature coming out of the pipe and I've only driven about 7 miles or so, and close to the exhaust brake, it's definitely quite warm, but as I go up that loop, it's just barely lukewarm, and that's after, you know, running a number of times on the way here with the exhaust brake on and the Jake brake on both, trying to feel it. I'm not really feeling the holdback power that I was hoping to feel. There is a difference. I can definitely feel a difference. At this point, I guess every little bit helps, but not quite what I was looking for. And on the gauge, we're right at like 40, 42 PSI. On one of the longer downhills, I actually downshifted a little bit and got the RPMs up a little bit more, and I got closer to 50 PSI. What's a little bit strange, and I'm a little surprised on this, is when I apply the Jake brake after the exhaust brake is already activated, I actually see a drop in pressure, which is pretty weird. You'd almost think you'd see an increase in pressure because of the way those valves are allowing that combustion energy to escape into the exhaust system. Now last night I called and talked to Blue Ox a little bit after the whole melting hose situation, and they said one of the ways that people tune it is they'll just do the truck at idle in neutral, they'll energize the exhaust brake, and then they'll adjust the guillotine into where the truck shuts off, and then back it off a little bit and go from there. So I don't know what that's going to do to the downhill pressure, but I'd imagine it's definitely going to increase the idle back pressure. So I'm going to try that, see what it does, and maybe we'll get a little bit more on the way home. So making adjustments on this is relatively easy. Just two tools. Got a 3/8 Allen, an adjustable wrench, and right on the bottom of the guillotine valve, there's basically a set screw. So once you break the nut loose, the deeper you screw that set screw in, the more it will open the guillotine, and the less back pressure you will have. The more you back it out, the more the guillotine will close and increase back pressure. All right, so I've gone through and I've backed it just about all the way out. So that guillotine is definitely closed. I hear a lot of air escaping here. Looks like it's coming through the V-bank hole. All right, so after making the adjustment and coming inside and looking at the gauge, I still only have that 20 to 22 PSI at idle, so it didn't change the pressure at idle at all, and it really didn't affect my idle RPM either. So I just have a feeling that so much of that pressure is leaking out right there, those V-band clamps. The kit only came with one gasket, so I put it on the exhaust brake side, thinking that that's the flow and that's more likely to have the leak, but it feels like it's coming out of both sides, even the side that's got the gasket. But it only came with one gasket, and the instructions only show it coming with one gasket. However, looking at some of the other stuff online, it shows that there should be a gasket on both sides of that, but I only got the one. So maybe I'll be able to find one locally. I don't know, and if not, it'll just have to do for now. The nice thing is, as far as our downhill goes, we were getting the right amount of back pressure, so maybe this is just going to limit how much I can get and limit it to the max. All right guys, back up the yard with Goliath, and I tested it again on the way back with the adjustment, and I still had the same amount of actual back pressure coming down a hill with RPM up as I did before making the adjustment. So I think with the leaks coming from the actual turbo flanges, that we're just not going to get any more pressure than that, but it's still at the maximum rated pressure that what Detroit says this engine can handle for exhaust back pressure before it overtakes the spring pressure and causes the exhaust valves to float. So I think for right now, we're going to let it ride. If I can find some gaskets for it, I'll grab them and put them in on another day, maybe while we're in Myrtle. But this video has already been more than a week, I think, in the making, and it shouldn't have taken that long. We've only got 2 more days until we head to Myrtle, and I've got a few other things I want to do. So the system is functional, and it's at that max limit. So I think we're going to let it ride for right now, and we'll see if we can make some improvements to it later on. But for now, we're going to end this video. So thank you for watching. I hope you enjoyed it, and until the next time we see you, keep those engines running.